Okay, people, we have gone from a rather odd-looking design to what now is hopefully a comprehensive and easy-to-follow model. We say hopefully because we will be sticking to the same method of visualization as we proceed. Great! We know you're eager to see what comes next. We're going to add business intelligence to the diagram. But what is business intelligence, and how does it fit into the picture? Remember the following. Business intelligence, or BI, is the process of analyzing and reporting historical business data. After reports and dashboards have been prepared, they can be used to make informed strategic and tactical business decisions by end users, such as the general manager. Concisely put, business intelligence aims to explain past events using business data. So, with this information, we can work out where the business intelligence rectangle should go. It must go on the left of the timeline, as it deals only with past events, and it must sit within the data science rectangle as a subfield. Business intelligence fits comfortably within data science because it is the preliminary step of predictive analytics. It makes sense when you think about it. First, you must analyze past data and extract useful insights. Using these inferences will allow you to create appropriate models that could predict the future of your business accurately. Great! Let's move on. How should we distribute the three terms that remain over here? Preliminary data report is the first step of any data analysis. It can also be considered as data science, so this term can stay where it is. As with reporting and creating dashboards, these are precisely what business intelligence is all about. So, we will neatly place these two into the orange rectangle. Fantastic! And that's pretty much it for business intelligence. Now, we delve into the controversial yet rapidly expanding field of artificial intelligence, AI, and its subfield, machine learning, ML. The ability of machines to predict outcomes without being explicitly programmed to do so is regarded as machine learning. Expanding on this, ML is about creating and implementing algorithms that let machines receive data and use this data to make predictions, analyze patterns, and give recommendations on their own. Machine learning cannot be implemented without data. Hence, it should stay within data analytics completely. This could be considered as a bold statement to make, as it is debatable whether this is correct. Some argue that data analytics and ML are two unrelated scientific fields. For the sake of argument, we will let the machine learning and data analytics rectangles overlap. And, in a moment, we will exemplify some areas that could be considered parts of both disciplines. Moreover, ML should expand slightly to the left of the vertical line. The reason for that is the increasing tendency towards applying machine learning tools to the context of business intelligence. Fantastic! You remember we mentioned artificial intelligence, right? By definition, it is about simulating human knowledge and decision-making with computers. It is quite a general term that can have a rather philosophical interpretation. We, as humans, have only managed to reach AI through machine learning, the discipline we just talked about. And, as data scientists, we are interested in how tools from machine learning can help us improve the accuracy of our estimations. AI is beyond our expertise. We have mentioned it just to avoid the confusion of where it stands relative to the other fields of interest. All right, let's provide a few examples. The demand for accurate, real-time dashboards opens space for machine learning applications. Machine learning software can pull data from third-party companies, such as Facebook or Shopify, detect new patterns from their data, and thus suggest real-time recommendations and insights to managers and other decision-makers. This is a great way to improve the performance of your business as soon as there is a chance to do so. In general, there is a lot of potential for development in this field. Turning to the other side of the vertical line, we can say client retention and acquisition are two typical business activities where machine learning is involved. It helps develop models that predict what a client's next purchase would be, for example. Since we could say data analytics and data science are applied in client retention and acquisition as well, we can leave this term right over here. Okay. ML can be applied to fraud prevention as another example. We can feed a machine learning algorithm with prior fraudulent activity data. It will find patterns which the human brain is incapable of seeing. Having a model which can detect such transactions or operations in real time has helped the financial system prevent a huge amount of fraudulent activity. These examples are probably not the first that would spring to mind when talking AI and ML. Usually, speech and image recognition are among the most popular examples, as they are already being implemented in products like Siri, Cortana, Google's Assistant, and more impressively, self-driving cars. Naturally, these two examples are outside the business context, and it is debatable whether they could be placed under the umbrella of data science, data analytics, both, or neither. As it is a hot topic for discussion right now, we think they are worth mentioning. However, to avoid further confusion and disputes, let's take speech and image recognition out of the picture. Finally, an example that is considered artificial intelligence, but not machine learning, is symbolic reasoning. It is based on the high-level human-readable representations of problems and logic. It was once a trend in the past when people were trying to create human-like intelligence. Today, though, machine learning is the only form of general artificial intelligence that is being applied, and symbolic AI is rarely encountered, let alone practiced. All right. So, along with speech and image recognition, we can remove symbolic AI from the equation also. This will leave us with only what we are interested in. Nice! Now, we would like to mention a term that has invaded almost all business and data science glossaries: advanced analytics. It is rather a marketing term, coming from people who want to say that the type of analytics they are dealing with is not easy to handle. This is a subjective way of looking at it. Often, intimidating-sounding terms are used to discourage learning and create prestige. However, we are here to attempt to clarify the terms within analytics. And advanced analytics is technically a term that exists. So, we will collectively group all areas of analytics under advanced analytics, with the idea that any part of analytics can seem advanced at first, but that no part is exclusively or permanently within this category. Perfect! Remember that all areas intertwine, and what we show here is not a strict representation of commonly accepted meanings and definitions. It is all matter of interpretation, and this graph is our vision of data science. The locations of some of the components in the diagram are somewhat controversial. However, we believe this is a very comprehensive depiction of what these disciplines are about and how they overlap. Before we wrap up, the position and the size of the rectangles show conceptual similarities and differences, not complexity. All right, great. Finally, let's refer to our infographic. You won't need all fields from the diagram because we will be concentrating on data science and its application in business. Therefore, this is the rectangle that we will be working on next. The infographic I am talking about looks like this. It may look a little complicated at first, but if you follow us through the next videos, we will explain it step by step. Thank you for watching.